Hi, and welcome to this re-recording of the part where we had issues with the sound in the last lecture before the Linux lecture. I hope that this time it is better. Um, so I will re-record basically the part that had issues with the sound. These are roughly the first 30 slides, I think, or 36 slides, something like that. And then the rest is fine. So that's when I realized that there were issues. I will actually put this recording with no questions in between, like the questions that we have in scalable learning, because it will get pretty tricky to get them to the right places. And after I'm done with this recording, I'm going to record the lecture for today, which is Tuesday, the 6th of February. And then I will also record the lecture for Thursday, where when we meet, and I will upload all of them. So I will basically try for the next couple of weeks or a few weeks or whatever is remaining in the course to have all lectures recorded on by Tuesday. So I have the lectures ready by Tuesday morning. So the one thing that we discussed in the previous lecture, and now I'm referring to the first video lecture, basically is how to provide the illusion of many CPUs. Basically, uh, what we call virtualization of the CPU, so that different applications will run on the same CPU, thinking that each one of them have the CPU all by itself. So virtualizing the CPU uh, is built on the concept of time sharing, where you basically share the time between the different processes, the different applications running, so, with some fairness mechanism, and giving each process some time on the processor until basically some of the processes will end, some of the processes will continue running basically forever or as long as your computer is running. So to implement virtualization, to implement this time sharing, you need low level machinery and high level intelligence. Basically, you need mechanisms to be able to do that. You need mechanisms to be able to switch between the different processes. You need policies or algorithms for changing and switching between the different processes, which one runs now, and these are called scheduling policies. We will talk extensively about scheduling. Actually, today we'll start talking about scheduling, but during the course, scheduling is actually a major component. So the abstraction that we have, that the computer provides, that the operating system provide for us as programmer, is the abstraction of a process. And a process is basically an instance of the running program. So suppose that you're running, for example, um, I mean, there are multiple users logged onto a server, for example, and each one of them is doing something different. So if you have ever SSH'd into a server, if you have ever logged into a remote server, for example, you can be running something completely different from other people. Um, Also, if you look at things such as Moodle that you use on the university's servers, Moodle is not the only thing that runs on the university servers. There are multiple things running, and there are multiple Moodle instances for multiple courses running, right? So you can have an abstraction of a process, which is an instance of a running program, and you can basically summarize a process by looking at the different pieces of the system that it accesses and the different pieces of the system that affects. So, for example, some processes will be accessing memory and disk. Some processes will be accessing the USB peripheral, and so on. So, this is basically what a process needs and what a process affects. There are different states for each process, so a process can basically be would require memory, some place in memory to store data and load data and so on and so forth. It's basically, I mean, we talked about the memory hierarchy in the previous lecture. So each process will have its own memory area, which we call the address space. It will have registers, and these registers are basically the program counter that is where what instruction is it going to run right now. Is it going to basically execute on the processor right now, the stack pointer and the frame pointer and all these pointers that it needs for memory, basically the branch and the bound point I mean the memory bounds of the process. It will also require persistent storage, basically disk, what files it accesses, what files it owns, what files it opens, and so on and so forth.